Faculty of Pharmacy, University of Jember, began with the establishment of the Pharmacy Study Program based on the Directorate General of Higher Education, Ministry of National Education Number Decree 937/T/2003 on May 7, 2003, regarding the Pharmacy Study Program Operational Permit. So May 7 is designated as the birthday of the Pharmacy Study Program, University of Jember. Based on the approval letter of the Director General of Higher Education number 3910/D/2008 on 7 November 2008 and Rector's Decree number 11057/H25/PS.8/2008 on 5 December 2008. Pharmacy Study Program was changed to become Faculty of Pharmacy, University of Jember.
The archipelago country of Indonesia is rich in natural resources, including the mega biodiversity. Bioprocessing for people prosperity should be conducted in accordance with environment conservation for mutual benefit. University of Jember is located in Tapal Kuta region, surrounded by the regency of Lumajang, Probolinggo, Situbondo, Bondowoso, Banyuwangi, where most of the community occupation are related to farm and fishery. This geographical set has led the University of Jember to have commitment as an excellent university in the development of science, technology, and art, with elaborative aspect to the environment, business, and industrial agriculture. The vision of Faculty of Pharmacy is to strengthen the university commitment in the development and implementation of pharmaceutical sciences and technology related to environment, business, and agropharmacy. This excellency is driven through application of pharmaceutical sciences and technology in development of natural products and pharmacy services. Insightful to the environmental and business is depicted through environmental sustainability, competitive products which gain high economic value. And agropharmacy is based on the development of natural products based on pharmaceutical added value and development of pharmacy services for agricultural and coastal communities.
Faculty of Pharmacy, University of Jember currently has two study programs, namely the Bachelor of Pharmacy Study Program and the Pharmacist Profession Study Program. Currently, the Bachelor of Pharmacy Study Program has A rating accreditation based on the decision of LAMPTGAS number 0090/LAMPTGAS/AKM/SAR/2/2020. Meanwhile, the Pharmacist Profession Study Program is operated based on Minister of Education and Culture Decree number 37/E/O/2014 about Pharmacist Profession Study Program Operation Permits at the University of Jember. Currently, the Professional Pharmacy Study Program has a B rating accreditation based on the LAMPTGAS Decree number 0313/LAMPTGAS/AKR/Pro/5/2017. Faculty of Pharmacy, University of Jember has several divisions and laboratories. First, Biology of Pharmacy Division consists of Pharmacognosy Laboratory, Phytochemical Laboratory, and Microbiology and Biotechnology of Pharmacy Laboratory. Second, Pharmaceutical Division consists of Technology of Solid Product Laboratory, Technology of Liquid and Semi-Solid Product Laboratory, Biopharmaceutical Laboratory, and Technology of Sterile Product Laboratory. Third, Clinical and Community Pharmacy Division consists of Pharmacology Laboratory, Clinical Pharmacy Laboratory, Community Pharmacy Laboratory, Experimental Animal Laboratory. And the last division is Pharmaceutical Chemistry Division, which consists of Pharmaceutical Analysis Chemistry Laboratory, Medical Chemistry Laboratory, and Chemobiosensor Laboratory. In addition, Faculty of Pharmacy, University of Jember, also has a Medicinal Plants Education Center or WETO as a display media for Indonesian medicinal plants. In the future, WETO will be developed into an educational tourist spot about various kinds of medicinal plants in Indonesia. For supporting the education process, Faculty of Pharmacy has been equipped with various adequate facilities such as lecture halls, laboratories, educational pharmacy, reading rooms, computer-based tests or CBT room, Wi-Fi hotspots, prayer rooms, parking lots, student organization and student activity unit building, and also a sports field. To support the research activity, Faculty of Pharmacy has formed several research groups or CREs. Among others are Drug Utilization and Discovery Research Group, Chemo and Biosensor Group, Preclinical Pharmacology, Medicinal Chemistry, Drug Utilization Research Group, Drug Delivery, Bioactive Natural Product Development, Chemometrics, Biomaterials and Bioproducts, Active Pharmaceutical Ingredients, Modification and Cosmetic Products. The entire research activity supports the achievement of the faculty's vision, which is to become an excellent faculty in the agropharmacy fields. Faculty of Pharmacy also has several student activity units and student organizations to support the self-development
of the pharmacy student outside of lectures activity, such as Charisma Student Activity Unit, Lingkar Pharmacy Student Press Organization, Philadelphia Christian and Catholic Student Activity Unit, Ashba Islamic Student Activity Unit, Pasadena Student Sports Activity Unit, SMC Student Art Activity Unit, and Recruiting Nature Lovers Student Unit. For the student organization, Faculty of Pharmacy has two student organizations, namely the Student Executive Board, or BMF, Faculty of Pharmacy, and the Student Representative Body, or BPMF, Faculty of Pharmacy.
Several achievements have been achieved by the students of Faculty of Pharmacy, University of Jember, such as winning a gold medal in PIMNAS 28 at Halu Oleo University Kendari, winning the Indonesia Pharmacy Student Scientific Week event, participating in national and international conferences, and many more. Not only students, but the faculty's lecturers also have very proud achievements, such as Professor Dr. Bambang Kuswadi, MSc PhD, who's chosen as one of the world's top 2% scientists by Stanford University. The Pharmacist Profession Study Program educates students to become professional pharmacists who are ready to enter the community and give a pharmaceutical service in pharmacies, hospitals, industry, and government organizations.
In addition to lecture activities by internal lecturers and guest lecturers, the Pharmacist Profession Study Program also carries out several activities such as Professional Pharmacist Work Practice or PKWA, Computer-Based Test Elimination Pharmacist Competency Final Exam or CBT UKAI Tryout, CBT UKAI Exam Objective Structured Clinical Examination or OSCE Exam, Community Service, and Pharmacists of Thinking. Faculty of Pharmacy, University of Jember has collaborated with various institutions such as School of Healthcare Professions, University of San Carlos, Philippines, University Science Islam Malaysia or USIM, Leibniz Institute for Plant Biochemistry or IPB Germany, and the University of Wollongong, Australia. For the PKPA program, Faculty of Pharmacy collaborates with Tawangmangu Center for Research and Development of Medicinal Plants and Traditional Medicines, B2, P2TOOT, Customer Complaint Service Unit, National Agency of Drug and Food Control, Longkampong, Jember, Pharmacy Installation District of Jember Health Department, hospitals, health centers, industries, and pharmacies. Faculty of Pharmacy has thousands of graduates or alumni spread across various fields of work and education and become members of Alumni Association, ICA Pharmacy, University of Jember. Several activities have been carried out by ICA Pharmacy, University of Jember, namely social services for the COVID-19 pandemic at Jember Regency hospitals and health centers, donation for victims of the eruption of Mount Semeru, and Munas ICA Pharmacy, University of Jember.
medicinal plant and traditional medicine or working group on MP and TM, an event held by them twice a year.
This year, the first international conference on medicinal plants theme is a revelation on medicinal plants as antioxidant sources against metabolic disorders, bioprospecting and conservation of Marsilia crenata and Garcinia mangostana.
This conference will discuss various papers on medicinal plants, including traditional Indonesian medicines, which cover the preservation and cultivation of medicinal plants. In this case, the emphasis is on jamu, post-harvest, phytochemicals, efficacy and safety, pharmaceutical technology, marketing, regulation, database development, and quality control.
Before we start, please let us introduce ourselves. My name is Muhammad Iqbal Ar-Rashid.
And my name is Cheryl Areta Pasaribu, and we are honored to be your host for today's conference. We would like to give the warmest welcome to the honorable guests and audiences here on the day 2 of the first International Conference on Medicinal Plants. Ladies and gentlemen, before we begin the conference, please allow us to first broadly go through the agenda as follows. Today's conference will consist of 2 plenary sessions, 2 parallel sessions with 2 breaks, and poster presentations in between. Right after this, we will be having our 3rd plenary session. There will be 2 presentations followed by a discussion segment at the end that you can participate in.
After the 3rd plenary session ends, please kindly go to the parallel room. The door is on your left inside the lobby because there will be an oral presentation from our invited speakers and oral presenters. We would like to kindly remind today's oral presenters to check ICMP's guidebook, which can be downloaded through ICMP's website.
The next agenda is an hour's break. During the break, you can go to ICMP's virtual tour that will lead you to various poster presentations in a short video form that you can freely choose from. After the break, please kindly go back to the parallel room at 1 p.m., 7 hours ahead of Greenwich Mean Time.
Right after that, we will have a 10-minute break to prepare for the plenary session 4. Just like the past plenary session, this one will also consist of 2 presentations followed by a discussion segment at the end, led by the moderator that you can participate in.
The last one is closing. There will be an announcement of the best oral and poster presenter by the chairman of the first International Conference on Medicinal Plants. Alright, without further ado, we are entering plenary session 3. For the 3rd plenary session, we will be having a presentation by Dr. Purpa Wangchuk from James Cook University, Australia, and Dr. Faizul Helmi Adnan from the University of Science Islam, Malaysia.
But first, with honor, we would like to invite Dr. Apoteker Agung Erwibowo, Master of Science from the National Research and Innovation Agency of Indonesia as the moderator for today's 3rd plenary session. Good morning, sir. How are you today?
Morning. Alhamdulillah, I'm fine.
Glad to hear that, sir. Before we begin, please let me briefly introduce the curriculum vitae of Dr. Apoteker Agung Erwibowo, Master of Science. Dr. Apoteker Agung Erwibowo, Master of Science is from Research Center for Pharmaceutical Ingredient and Traditional Medicines, National Research and Innovation Agency. He completed his biomedical doctoral program in the University of Indonesia on 2011. His areas of expertise are agriculture, biological sciences and forestry, biochemistry, genetics and molecular biology, health professions, immunology and microbiology, medicine and pharmacology. Dr. Apoteker Agung Erwibowo, Master of Science, has published some research papers. The last one is entitled Effect of Seahorse Extract on caspase-3 and tunnel assay in rats after depot medroxyprogesterone acetate induction on 2022. And that is about our moderator for our 3rd plenary session. Without any further ado, to Dr. Apoteker Agung Erwibowo, Master of Science, the platform is yours.
Yeah, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning, ladies and gentlemen. Thank you for this time. And my name Agung Eruwibowo. I am from National Research and Innovation Agency. Nice to meet you all, and thank you for all participants and of course for speaker have attended in this session. Ladies and gentlemen, in this morning, in this session, we have two great speakers. The first one is Dr. Purpa Wangchuk from the James Cook University, Australia. And then the second one is Dr. Faisal Helmi from the University of Science Islam, Malaysia. In this session, all the speaker will be present until finish, and then we continue to the question and answer session. Ladies and gentlemen, I would like to invite the first speaker, Dr. Purpa Wangchuk. Hello, Dr. Purpa. Nice to meet you. Sorry, maybe you voice not yet covered. Okay.
Good morning.
Good morning. Yeah. Good morning. Yeah. Thank you. Yeah. Dr. Purpa Wangchuk will be deliver presentation about the bioprospecting antioxidant plan for the combating metabolic diseases. Before Dr. Purpa Wangchuk deliver the presentation, I will read curriculum vitae of Dr. Purpa briefly. Dr. Purpa Wangchuk from the, I'm sorry, this not clear. Yeah. Yeah. Dr. Purpa Wangchuk come from the Australian Institute of Tropical Health and Medicine, Center for Molecular Therapeutic, James Cook University, Australia. And the last education from him is Master Science in the Medicinal Chemistry, and then PhD from the University of Wollongong, Australia. And he has area of expertise mainly on the medicinal and biochemistry, biomolecular chemistry. And of course, Dr. Purpa, so many publications, and including about this comparative analysis, isolation of antibacterial from Indonesian lichen, and also immunomodulator, and etc. And Dr. Purpa, I think, so many awards, and one of them in 2020 until 2022, have the award from the National Health and Medical Research Center. Dr. Purpa, you have about 40 minutes, and when the time 5 minutes left, I will rewind you. Time yours.
All right, thank you, Chair. I'll share the screen now. Can you see it?
Yeah, it's clear. Yeah.
Can you see it in PowerPoint mode? Or can you see it?
Yeah. Okay, it's clear, Dr. Purpa.
Is it clear? Is it in PowerPoint mode?
Yeah.
Okay, thank you. All right, thank you, Chair, Dr. Agung, and also thank you everyone for attending this talk today. We had wonderful session yesterday, session including the panel as well as the speech from different office holders, including ministers and also directors. It was really good and inspiring to hear that. And I would like to thank once again, the organizer of ICMP, International Conference on Medicine Plants. This is a great opportunity to gather together, share what we do, and then probably that may lead to collaborations in future. So without further ado, let me just start my talk on bioprospecting plans for combating diseases of the tropics. Now, after having attended talk yesterday from both plenary speakers as well as the invited speakers and oral presentations, I heard lots on metabolic diseases, including diabetes, antioxidants. So I thought maybe I should throw some different perspective on the presentation today. So it may be a little bit different from what you may see in the book. Now, I will be focusing on the tropical plants. You may wonder why tropics. Why do the tropics matter? The reason is quite obvious. About 134 different nations and territories fall under the tropics. More than 50% of the world population live in the tropics or will be living in the tropics. 80% of terrestrial biodiversity, 95% of coral and mangroves thrive in the tropics, and mostly from Indonesian island. Now, 50% of non-plant species originate in the tropics, so it's a huge share there. And also, it matters because places like Australia, Northern Australia, and also Jesu in particular, as well as Indonesia, we are in the heart of the tropics, you can say, therefore we share some common geographical features. So I think it's important to discuss what we have, where we are, and how we can go about that. Now, I'll be talking a little bit on the state of the tropics. Some of you may have heard about that, and I think that's important to discuss this here before I present my main talk, to throw the context. Now, what is the state of the tropics? Well, it's a global alliance of institutions working towards a brighter future for the tropics. It was established sometime around 2011.
Dr. Pupa, I'm sorry. So please you display full this screen. So
is it better?
Yes, right. Great.
Okay.
Sorry.
So that was my PowerPoint mode. All right. So 2011, different researchers got together, with common interests to work for the future of tropical world. They came together, examined the condition of life in the tropics. The main aim of that state of the tropic that time was to build effective partnership between tropical research institutions, build local research capacity, and work towards achieving a sustainable, prosperous, and equitable future. And that's important even for this conference. I think we need to have some common ground, find common ground where we can do this sort of both research as well as capacity building. Now, every year they have been producing State of the Tropics report, 2021, 22. It has been dominated by COVID-19 in the tropics. But this report in 2019, before COVID pandemic happened, they produced this wonderful, fascinating report on the general health burden of the tropics. So this identified about more than 10 to 15 different health burdens that affect mostly tropical countries, including Indonesia. And HIV/AIDS, malaria, and tuberculosis remain major cause of mortality and morbidity across a large portion of the tropics, not only in Africa, but across the globe, around the tropics. Neglected tropical diseases, about 20 diseases defined by WHO, and non-communicable diseases, including lifestyle diseases that include diabetes, are also the top 10 diseases of the tropics. Now, in the tropics, unlike other regions, especially non-tropical countries, we in the tropics have so-called the double burden of disease, where rates of the non-communicable diseases, which is disease of the developed world or other nations, continue to increase alongside rates of infectious disease. Infectious disease is more in the tropical countries. You can say most of them endemic. So okay, so now the thing is, we know those diseases, about top 10, and most of the tropical countries are focusing to elevate some of those diseases that affect tropical countries. Now, the question is, can medicine plants or herbal medicines, save people from those infectious and non-communicable diseases that affect the tropics? That's the question. Right? We have heard yesterday, and also today we'll be hearing lots about this. One advantage of being in the tropical countries is that we have rich tradition of ethnobotanical knowledge, as well as we have rich biodiversity. So we can bank on those resources, and definitely you can find some solution. About 50,000 medicine plants are used in traditional medicines worldwide, mostly from tropical countries, including Indonesia. And we heard yesterday as well from the directors that during the COVID-19 pandemic, a lot of people in Indonesia used herbal medicines to boost their immunity. Now, this is not the case with Indonesia. This happened worldwide because most of them wanted to stay healthy. There are a lot of good fruits, good bush medicines, including ginger, garlic, etc. So definitely, yes, there are things that we can look upon traditional medicines and then say, yes, we have relied onto it for so many years, and we still keep on relying on traditional medicines as a primary healthcare service provider, mostly useful for preventing, you can say, preventative care. And it has also been guiding the biodiscovery or bioprospecting works for many years, and it still does so. About 1/3 of plants that are used in pharmaceuticals have been discovered from the tropics. Now, thought maybe this would be interesting for you to show this one. This is the data that we published sometime in 2016. That table shows that Indonesia has 4.4% utility of the medicine plants or biodiversity out of 22,000. This is a bit old data. Yesterday we heard it's more than that. Benefits. Now, what are the benefits from herbal medicines? Like, like I asked the questions, or we can ask a lot of questions, but are there any benefits from herbal medicines? People have been, we know that people have been killed, countries have been conquered, colonized just for spices, herbs, medicine plants. So definitely, yes, there are heaps of benefits. It's one of the valuable and well-protected commodities of the past, present, and present economy as well, and it will be so in future as well. All countries combined, we spend about USD 60 to 100 billion per year in just trade deals. That's WHO report. USA alone has spent about 2.7 to 5 billion, followed by China and US. In Australia, we spend about 2 billion in out-of-pocket expenses on herbal medicine or complementary alternative medicine. That's what we call here. Now, that's more than the out-of-pocket expenses that we spend on pharmaceutical product, prescription drugs, which is only 1.6 billion. And chem industry in Australia generates about 4.6 billion per year, and it's a huge market. Now, we know the market, we know the economics of those herbal medicines. Now, what can we do to improve the herbal medicines? If you improve the quality, there are even more better chances of, increasing those, you can say, economics of herbal medicines. Now, conferences such as these definitely can help improve the knowledge about the diseases, the botanical solutions, and the better tools that we can identify from herbal medicine to combat the diseases. It was very encouraging and inspiring to hear how Indonesia is ramping up the development of herbal-based products. We saw a lot of products yesterday, and also initiating biodiscovery activities. Now, to improve the quality of herbal medicines and initiate bioprospecting or drug discovery, it needs policy changes, government support, finance, most important and critical, research facilities, and technical expertise. And through this presentation, probably we will find some common ground, what we have, what you may have, and then, and also other collaborators, what you may have, and then find common ground to collaborate, especially in the area of drug discovery and development, because it requires collaboration among traditional healers, universities, pharma companies, and it's not a one-man show. So when we talk about drug discovery or by discovery, what are we saying? It is the process by which new medicines are discovered from various sources, including synthetic chemicals, biochemicals produced by different living organisms. Living organisms, as we all know, produce very interesting chemicals in order to adapt, defend, and survive. And we have learned to utilize those chemicals. Now, in order to do that, for biodiscovery, so what you're seeing there is this the normal process of drug discovery process here. So let me just show with the laser. So you can see here, in vitro and in vivo testing, early biodiscovery process, and that's what I'm going to present today. And that's critical for any drug discovery. And then once you get the compound or drug lead identified, patent them, do the clinical testing, and then you have others that follows, including FDA approval. Like in Indonesia, you may have FDA as well. Now, for drug discovery, especially from natural products, we can use at least 3 different approaches: biorational, chemorational, and random screening. Random screening can be applied to those processes, especially marine natural products where you don't see any traditional uses. Now, biorational approach is the one that I'm going to focus for today. What we use there is that we use ethnobotanical guided approach as well as evolutionary or ecological based approach. So those are the 2 things we usually follow in the drug discovery. Now, drug discovery from ethnobotanical plants, as we all know, it has a proven record of long clinical uses. It has been used for thousands of years. Through trial and error, we learned to still use both toxic as well as non-toxic plants for medical purposes. Medicine plants shows higher hit rate of bioactivities. For example, in National Cancer Institute in USA, they reported that medicine plants extract get greater bioactivity hit rates than just randomly collecting their plants not used medicinally, collecting and screening. You don't get much activities. Now, this is a bit old data by Fabricant and Farnsworth, developed in 1981 to 2021. About 80% of the 122 plant-derived drugs were discovered from medicine plants. So it's a huge share there. And most of those drugs, most popular ones are morphine, quinine, artemisinin, taxols, and aspirin. And we saw that one yesterday as well from different places. So what do we use, or what do I use for my drug discovery approach? So these are the 2 things that I shared earlier. I use 2 approaches. One is purely based on ethnobotanical knowledge of the indigenous people. Here with the Aboriginal people, I have to work closely with the Aboriginal people, and we have been also working closely with different ecologists to based on evolutionary processes, we try to identify interesting resources for drug discovery processes. All right, so now I'm going to show you about fasting, about the ethnobotanical guided drug discovery processes. So what you are seeing there is, I've been mainly focusing on screening antimicrobial, anti-malarial, anti-diabetic, anti-inflammatory, but here I'll give you just one case study on the anti-inflammatory component. Now, to start with any biodiscovery or the drug discovery process from medicine plants, first thing we need to know is what do we have? Are those plants studied before? Are those plants utilized for treating certain diseases that we are interested? So these are the questions we ask. And in order to do that, we have to first do the literature review, as we all know. And we found that about 1,511 plant species are recorded in Australia. Most of them studied from Northern Territories, New South Wales, South Australia, and Western Australia. Not much from Queensland. So we did a literature review dig into TIEC database. It's a Traditional Indigenous Ethnobotany Center database where they, Jerry Turpin, who you are seeing there, he's the indigenous ethnobotanist, so he records everything there. So we found 100 and about 135 species, we found have really good, interesting medical histories. So we published that data. You can read that paper. Now, what we found when we did that review was that most of the plants that were used in Queensland medicine plants were belong to the life form called trees, followed by shrubs, then you have herbs, and then climber. And that is obvious because we are in the tropics. We have a lot of big trees here. In terms of the parts used, you can see leaf bulk of leaves are used here, followed by bark, roots, and also saps. And then you have here the different types of diseases. From that review, we found about 62 different types of disorders are being treated by Aboriginal medicine plants in Queensland. And what you are seeing there is we have tried to categorize into different systems because it was too big to categorize by individual plant. So what you are seeing there is nervous system that includes pain, etc., comprises bulk of the uses, followed by integumentary system, which is skin infections, etc., and then digestive system, which is your gastrointestinal problems. So my interests or our group focuses on the gastrointestinal disease that includes diabetes, stomach pain, diarrhea, indigestion, appetite loss, ulcers, and we have identified about 34 species with that uses. Now, let me tell you why we focus on digestive disorders. Partly because Australia has one of the highest incidence of inflammatory bowel disease that is related to your digestive system, including colon. So approximately 1 in 250 Australians suffer from IBD, inflammatory bowel disease. Current treatments are not effective. There's no cure to it. And the management of those, you can say IBD, includes Crohn's and colitis. Management of those diseases are expensive and has a lot of side effects. Current drugs has a lot of side effects. So therefore, there was need for novel drugs that can be, crude or the isolated compounds. Now, interestingly, when we did the review, we found that, of many patients, of different types of patients, cancer patients, IBD patients, and diabetes patients, what we found was IBD patients use the complementary or herbal medicines most. So you can say 21 to 60% of IBD patients used them in 2011. Now, IBD, interestingly, in the Aboriginal population in Australia has lower incidence of IBD rate compared to the non-Aboriginal Australian population. So that's interesting because part of the reason could be because they eat a lot of bush food, bush medicines, or vegetables. I'm talking mostly about the people who live in the rural areas. So Aboriginal medicine plants in general is less explored, not much. So we are doing that now. And in doing so, what we have done is we thought focusing on just overall Queensland is too big. So we wanted to focus only plants found in the tropic. You can see in the map here. So what you can see is, you have that James Cook University right in the middle of the wet tropics here. So we are located here. And we found about 78 medicine plants species that grow in the tropical region. About 45 of those species have been studied before for different biological activities, including anti-inflammatory properties. And about 83 compounds that were isolated from those 45 species were also tested for anti-inflammatory properties. So a lot of work has been done, but most of those studies were done outside Australia. Can be in China, somewhere in Indonesia, Malaysia, Thailand, etc. From the wet tropics, we have identified about 30 medicine plants, and we are currently focusing on that. So you can see wet tropics there. So our study focuses mostly on plants that are found in wet tropics. Now, when we do the biodiscovery process, there are a lot of things. You have to bypass all the regulatory aspect. You have to get approval from different authorities. You have to, then only you can start your lab work. So it is not just lab work that you can focus on. You have a lot of things to follow. So first thing what we do here in Australia is, especially at JSU, is we have to build relationship with the indigenous communities. If you're working with medicine plants, if you're working with different biological activities, for example, plants from the mountaintop or from the oceans, then you just get straight permit from the government. But if you're working with the indigenous communities, you have to get the this collaboration built beforehand, because you need to get those knowledge from them. And in order to do that, you have to gain some trust. Once you gain that, then you have to get ethics, human ethics, to further follow on biodiscovery work. We have to sign a collaborative agreement after that, followed by biodiscovery approval. We have to get it from the government, Queensland government. We have to get collection authority. Once you get it, then you have to sign beneficiary agreement with the Queensland government. Now, it's interesting to note that Biodiscovery Act is only in Queensland. Other states are following, so we are leading here. So we have to sign all those requirements, meet those requirements, and then we can start collecting plants. Once we collect, then it's ready to go. All the drug discovery process, including isolations to the biological activity screening, and then in the process, we have to, from time to time, meet together with the community, discuss the developments and the progress of the project, and then we share. And also in the patent process, we have to involve them. Patent is on 50-50 by the community and the university, whoever collaborates with them. Now, in the laboratory, we have this process. I think we heard that from yesterday as well from many speakers. What we do is we collect plants, get the extract, do the fractionation, do the purification. We use metabolomics for dereplication. We use NMR, MS mass spectrometry for structural elucidation. Once we get compounds, pure compounds, we test them again for different disease models, mostly anti-inflammatory. We have anti-diabetic screening as well, antimicrobial, anthelmintic screening. So we have all those models here at JCU. And then once, depending upon how strong or good the candidate is, then we identify the drug lead candidates. So this is the case one study that I'm going to present here today. So case one is the antioxidant and anti-inflammatory activities of medicine plant from Central Queensland. So what we did is Jerry Turpin, who is ethnobotanist here. So we go there to the meet with the communities, identify botanically, collected those plants. We collect from different parts of the region, collect them, and then bring it here. And that's what we did here. We collected them, screened them firstly for antioxidant properties, because there's direct link between antioxidant properties and anti-inflammatory properties. So, if you see good or strong antioxidant activities, most of the time you get good hit for anti-inflammatory when you do anti-inflammatory screening. So we did the DP-based screening as well as followed by PrEP. So this is the result for DP-based result. I saw some of the talk yesterday that you had really interesting antioxidant screening in Indonesia as well. So anything that you see in the studies are those plants that show strong antioxidant properties. Now, what you are seeing there is we codify the plant because we do that partly because it's the requirement of the Biodiscovery Act that we protect the indigenous knowledge. So anything we get from them, we have to identify, code them. Even testing, we have to code them. And then, once we get something out, once we publish, then we can disclose that plant. So that's why you see everything coded there. Now, what you are seeing there is you have here, which is, IC50 values of those plants. Only 4 plants showed significant antioxidant activity. The best one is TB75, equivalent to garlic acid. This is the standard we use here. Again, one assay was not good enough, so we had to confirm. So we confirmed using PrEP assay. Again, we found like similar correlation or similar antioxidant properties for compound 1, 3, and 4, which show the best antioxidant properties. Now, depending upon the bioactivities or antioxidant properties of those initial screening, we selected about 8 different plants for anti-inflammatory screening using the peripheral blood mononuclear cells assay, PBMCs. So what you are seeing there is, we extracted different plants, concentrated it, and then reconstituted it in the media, and then co-cultured them with LPS activated PBMCs, about 100 microgram per ml concentration, and then we measured the cytokines. What happened is, in the inflammatory process, including inflammatory bowel disease, when you get that disease, you get a lot of inflammatory cytokines or molecules. You call it molecules, cytokines. So what they do is they secrete a lot of cytokines. So if you have products or the extracts or molecules that can suppress that inflammatory cytokines, then that's a good thing. Right? So we did that one, and then we measured it using flow cytometry. Now what you are seeing there is, you can see this dexamethasone, currently used drug, anti-inflammatory drug. You have DMSO stimulated with LPS. That's what you expect to see, like interferon gamma, IL-23, MCP1. There are about 13 different inflammatory cytokines that affect patients suffering from inflammatory bowel disease. Here we have only 4. So when the cells are inflamed, that's how you expect to see. And then when you give drugs, it has to bring it down. Same thing has happened with our plants. You can see TB75, 88, 89. So extremely good, even comparable to the DMSO. So it has done similar, you can see similar pattern in other inflammatory cytokines as well. So you can see TNF alpha, IL-23, the most active ones are the one that you see at the bottom here, which is TB79 in this case, TB79. So we have identified about 5 different potent medicine plants for further screening. The next step would be to isolate compounds and then do the preclinical studies in mice. So that is the case study about the ethnobotanical study. So we are in the process of doing it. But I want to show you second case studies about the ecologically driven studies or biodiscovery processes. So I'll be focusing on plants that are affected by climate change. Now, climate change is a big issue in the tropics, including Indonesia. In Australia, the tropics, especially wet tropics, have been drastically affected. Ecologists here, they have identified over 70 species threatened by climate change, and around 50 years from now, they expect those plants to go extinct. So I have worked closely with ecologists, identified at least few species, maybe 10 to 14 species from different mountaintops here. Now the rationale is that as there's global warming, plants tend to migrate to the cooler areas, mountaintop, and in the process of adapting, they produce a lot of interesting metabolites, mostly anti-inflammatory. So that's the rationale behind this ecological based screening. So this is the data for 7 species that we have screened. I have not shown one here, but 7 species. First we did was cytotoxic screening. None of them were toxic, which is a good thing. And then we followed the anti-inflammatory antioxidant screening by DPPH and PrEP assay. About few of them showed really strong antioxidant properties. And then this is the cytotoxicity. None of them were toxic. And then we did the anti-inflammatory screening. So what you are seeing there is, again, we did similar approach with the PBMC assays, co-cultured them. And then what you are seeing there is, you have A, which is TNF alpha, B, interferon gamma. Now, these are, again, the inflammatory cytokines involved in the pathogenesis of inflammatory bowel disease. So if you find some compounds or some extract that can suppress those inflammations, is a good news. So you can select that candidate for drug discovery. So in this case, you have drugs here, and then you have Garcinia brasei, which is extremely good here, significant, highly significant, it's bringing down everything. And same thing, IL-23, you have LA, different plant, and Garcinia brasei. So we have selected Garcinia brasei and Euromyretus for further screening. That includes phytochemical as well as biological activity screening. So I'm going to show you what we have done with one of the plant from that mountaintop species affected by climate change. The plant is called Euromyretus metrosideros. It's only found here in the wet tropics in that particular area, not found in Indonesia as well. So we collected that plant, dried them, extracted, and then put it through HPLC. That's how you get the HPLC profile. We got about 6 compounds, and these are the compounds here. These are the non-compounds, norberginin, berginin, rosicide, and then I've not given the name of the drug lead compounds here. Euromyretuside is the new compound that we have discovered, so we named after the species. And you can see these are the relative abundances of each compound. Now this is the photo of the plant and the structure of the non-compounds from this plant. So I've not given the structure of the drug lead compounds here, including the new structure we have established. We tested those compounds again for toxicity using the real-time glow empty cell viability assay. Now what this means is if you see the reduction in luminescence, that means compound is toxic, it causes cell death. So that's what you expect. For example, this is untreated, which means nothing there. Lysis buffer is the one that kills the cell, so you expect to see that down. And then you have compound 3, 4, 5, 6. And you can see within 1 to 24 hours, you don't see any toxicity there, which is good thing. And then, if you see any toxicity, that's when we discard. There's no point, taking it further because, it's the hurdle for developing it further. So if you don't see toxicity, then we do it anti-inflammatory screening, both in vitro as well as in mice, preclinical validations. So what you are seeing there is you can see, of all the cytokines that affect inflammatory bowel disease, about 4 of them. And you can see that compound suppress 4 of those inflammatory cytokines. IL-17A quite down, IL-18, IL-17A, even TNF alpha, which is important in here. Now, when we screen for anti-inflammatory activities for pure compounds, we use 2 different models. First one activated with the ionomycin, and the one activated with Dynabase, especially T cell activator CD3 and CD28, because different compounds affect different, you can say T cells. We tested them about 10 microgram. We use cyclosporine as the standard. So cyclosporine is this one here. So it reduces inflammation very dramatically. Our compound is not so bad here, especially in reducing IL-20, IL-17A, and interferon gamma. So that was good news. So what we did is we have patented that compound, provisional patent. Now we have to do the preclinical evaluation, which is next step, and then you collaborate with different pharma companies, see whether they are interested or not, and that's how we will go about. Now, in conclusion, I would like to say that drug discovery is a complex process where various disciplines such as chemistry, biology, immunology, and pharmacy collide, as well as intersect. Right? And when this collides, a lot of interesting ideas comes forward, because there are a lot of different paradigms, different theories, different techniques involved in that. So it's merger of everything. It's not one man's show, as I said earlier. That's where you need collaborations, right? Now, tropical region is rich in terrestrial medicines and biodiscovery, as we have seen, biodiversity, as we have seen yesterday, and also we'll be hearing a lot today as well. Medicine plants provide us with a lot of health benefits. It also guides drug discovery. You can make a lot of nutraceutical products, a lot of cosmetics, you name it. So it's a big potential there. And also it's a big commercialization product that you can bank upon. you can have that as a good selling point for the tropics. It has saved many lives for thousands of years, and it still does. Now, for anything that we do, collaboration is the key to achieve the goal of the state of the tropics. So if you read that state of the tropics, you'll get insights into what are the visions, goals, and what we need to do it together, especially in the tropics. Institutes, researchers from the tropical countries, right, to make the tropical countries healthy, wealthy, and wise. Now, when we talk about collaboration, I have good collaborator, Professor Ari from Jambal University. We have been working with Indonesian medicine plants for quite a while now. So hopefully, we get to do that here in Australia as well. Now, lastly, I would like to thank my people who were involved in those drug discovery screening works. Editor, Karma, Jerry is an ethnobotanist. Andres, and I have new person here. And also we got big funding from National Health and Medical Research Council. And we are doing that drug discovery on one of the communities here in Australia. I would like to thank Queensland Hospital Foundation, because they have given a small pocket of money where we do this preliminary screening. And then once we have that preliminary result, then we can apply for bigger funding. So it's a good system here. And lastly, once again, I would like to thank the organizer of the international conference on medicine plants. Thank you.
Okay, thank you, Dr. Pupu. The time is right. Only left 2 minutes left. Thank you. And very nice and very interesting presentation. I'm very happy, and several things I try to note. First one about this tropical disease, and then about the potential of the biodiversity is very important also. And then Dr. Tulfa also complete presentation about the bioprospecting, and especially in vitro and in vivo bioassay, and also the important thing also about the biodiscovery strategy. Okay. Please, all of participants, if any question, please write this chat box. And if want to take rate delivery, maybe on the question and answer session. Once again, thank you, Dr. Purba, for this great presentation.
Thank you, Dr. Akung. Can I stop sharing it so I can see you guys?
Yeah,
so I can see you. Okay. All right. Okay, thanks.
Yeah. Thank you. Okay, ladies and gentlemen, now I will invite the second speaker. He is Dr. Faisal. I'm sorry, Dr. Faisul Helmi bin Adnan from the University Science Islam Malaysia. Assalamualaikum, Dr. Faisul.
Waalaikumsalam, Dr. Agung, Bapak Agung. Apa kabar?
Terima kasih. Thank you for join this session. And ladies and gentlemen, Dr. Faisul will be presentation about the medicinal plant and their potential role on diabetes. And before Dr. Faisul presentation, maybe I will read this curriculum vitae shortly. Maybe I can, yeah. Dr. Faisul Helmi bin Adnan from the Department of Medical Sciences, Faculty of Medicine and Health Sciences, University Science Islam Malaysia. His last education as Master of Science on Nutritional Biochemistry from University Putra Malaysia, and then PhD on Medical Biochemistry from the University of Newcastle, New South Wales, Australia. And Dr. Faisul have area of expertise on the nutrition, biochemistry, and also inflammation. And of course, he has many publications including about the gut microbiota composition on pre-diabetic is very interesting also, and the impact of COVID-19 pandemic on children, high prevalence of the back pain, and identification of phytochemical. And also, Dr. Faisal Helmi have awards. One of them is Anugerah Perkhidmatan Setia University Sains Islam Malaysia. Okay, Dr. Faisal, you have about 40 minutes, and I will remind you when 5 minutes left. Time is yours.
Okay, thank you so much, Dr. Agung. I will start sharing my screen now. I hope my connections are stable, yeah?
Okay.
Sorry. Okay, just want to check, Dr. Agung, can you see my slide now?
Yes, your slide is clear in my screen.
Okay.
Very clear, yeah.
Okay, thank you. Okay. Assalamualaikum and very good morning to everyone. First of all, I would like to thank the organizer for the kind invitation. It is a great opportunity for me to be able to share knowledge or information to speak at this conference, the first international conference on medicinal plants. And non-communicable diseases, in particular cardiovascular disease, is a major threat worldwide. In Malaysia, for example, these kind of diseases, CVD, are the leading causes of death. And among major risk factors that have been identified that are associated with cardiovascular, high blood sugar, high blood pressure, high cholesterol. One of the risk factors that is strongly associated with cardiovascular disease is the metabolic syndrome. I'm sure all of us here are very, very familiar with this terminology, metabolic syndrome, where a cluster of conditions that's occur together. So this condition include increased blood pressure, high blood sugar, excess body fat around the waist, and also the range of blood lipid profile, specifically with high level of triglyceride and also low level of high density lipoprotein cholesterol. And this morning, my presentation will focus on high blood sugar diabetes and the potential role of medicinal plants against this disease. Okay, this outline of my presentation today. I will not having a very comprehensive presentation, I must admit. Just to compare with the first speaker, which is Dr. Purpa, has presented a very excellent, very comprehensive presentation. But nevertheless, I will try my best to give mostly on this summary, the findings so far regarding the use of medicinal plants against high blood sugar. Of course, to facilitate the understanding, first we must know the knowledge with regard to the medical sciences, with regard to the pathogenesis of the disease. Okay. Okay. International diabetes federations have published recent data on the prevalence of diabetes in 2021. We can see clearly from the slide. Currently, 537 millions of adults are living with diabetes. 3 in 4 adults with diabetes live in low and middle income countries, and 6.7 million deaths due to diabetes in year 2021. Increased trends of diabetes in year 2021 were observed compared to data reported in year 2011 and 2000s. And rapid urbanizations and economic development, especially in developing countries of the world, have led to a dramatic change in nutrition and dietary intake, as well as in physical inactivity, both of which are related to the obesity and diabetics epidemic. This is what we call lifestyle that contributed to the deranged metabolic profile in our body. Across region, number of people with diabetes are projected to increase in year 2030 and 2045. Of particular interest is the Southeast Asia region, where countries like Malaysia, like Indonesia are located. The number of people with diabetes in this region expected to rise 68% in year 2045 compared to year 2021. Based on this alarming prevalence of diabetes and the burden caused by this disease, there is a strong need for effective intervention strategies as well as policies to solve the increase in the number of people developing diabetes. Of course, this disease, if left untreated, will significantly decrease quality of life. Uncontrolled diabetes lead to severe complications, including heart disease and stroke, diabetic retinopathy, diabetic nephropathy, and also diabetic neuropathy. Economic burden is huge on the flip side. 11.5% of global health expenditure spent on diabetes in year 2021. So that was US dollar about 966 billion. Pharmaceutical industries react with this trend by designing new anti-diabetic drugs molecule with a new mode of action. And the treatments of diabetes aim to reinstate and preserve blood glucose level to their normal values with the use of anti-diabetic drug by intervening on different pathways responsible, particularly on glucose metabolism. Investigations or exploring natural compounds having anti-hyperglycemic properties are intensely carried out across the globe. Now let me move on the pathophysiology of diabetes. A brief introductions about the diabetes. Diabetes mellitus is a heterogeneous disorder defined by the presence of hyperglycemia. There are two major types of diabetes mellitus. The first one is a type 1 diabetes, where beta cell destructions leading to absolute insulin deficiency. And type 2 diabetes, which may range from predominant insulin resistant with relative insulin deficiency to a predominant secretory defects with insulin resistant. Type 1 diabetes is less common compared to type 2 diabetes. And because of that, my presentation will focus more on type 2 diabetes and the potential of medicinal plant have, again, this type 2 diabetes. And insulin resistance is the hallmark of type 2 diabetes. And the next couple of slides, I will explain a little bit about the physiology and biochemistry of insulin in order to facilitate our understandings on the diabetes. Metabolic processes are tightly regulated to maintain glucose homeostasis, and two very important or quintessential hormones are insulin and glucagon. Glucose homeostasis basically are maintained by glycolysis, glycogenesis, glycogenolysis, gluconeogenesis, lipolysis, and also lipogenesis. The main characteristics of pancreatic function in a healthy individual versus diabetic individual are summarized in the figure shown in the slide. In a healthy individual, the pancreas respond to hyperglycemia with insulin secretion, aiming to maintain glucose homeostasis, so that the biological function of insulin can take place in the cell, which is the prime function is to promote the glucose uptake by the cell. Diabetes occurs when the pancreas fail to produce insulin, type 1 insulin dependent, or when insulin produced is insufficient to produce glucose homeostasis. Insulin is synthesized in proinsulin form in the beta cell of pancreas. Looking at the proinsulin form, it consists of A and B chain joined by C peptide. A and B chain are covalently linked by two disulfide bond, and A chain has one disulfide bond within. In circulatory vesicle, this proinsulin is cleaved to form insulin and C peptide. And because of that, measuring C peptide also can give an indicator of level of insulin that is secreted by the beta cell of pancreas. The figure shows how the beta pancreas synthesis the insulin. Glucose is the primary physiologic stimulant of insulin release, and glucose entry into beta cell is facilitated by one or more glucose transporter. And one in the cell, the metabolism of glucose stimulates insulin secretions. Glycolysis produces an increase in ATP within the beta cell, which is sent by sulfonylurea receptor subunit of ATP-dependent potassium channel in the beta cell membrane, resulting in a closure of channel caused depolarizations inside the cell, thus triggering exocytosis of insulin containing vesicle granule. Drugs, one of the available in the markets to combat hyperglycemia is the use or administrations of sulfonylurea, and this drug basically works by stimulating release of insulin in a glucose-dependent fashion, where this sulfonylurea activate the closure of the potassium channel. And antiretroviral hormone, for example, GLP-1, glucagon-like peptide 1, have been shown to enhance glucose-stimulated insulin secretions in beta cell. The primary actions of insulin is to trigger translocations of glucose transporter, mainly insulin-dependent glucose transporter, which is GLUT4, from cytosol to membrane in insulin-dependent peripheral tissues. Insulin receptor composed of 2 alpha and 2 beta subunit, and binding of the insulin to its receptor cause phosphorylations of insulin receptor substrate, and this lead to autophosphorylation or stimulating complex intracellular signaling pathways, for example, as shown in the slide, for the purpose of metabolic pathway, transcriptional pathway, and also mitogenic pathway. For instance, metabolic pathway mediated by activations of phosphatidylinositol 3 kinase lead to the phosphorylations of protein AKT, and these trigger or sensitize the GLUT4 which primarily reside in the cytoplasm to translocate to the cytoplasm so that the glucose can enter the cell for the utilizations. Insulin resistant lead to the elevated level of glucose and also elevated level of unesterified fatty acid. Inability or impairments of insulin lead to dysregulations of fuel homeostasis, and basically metabolisms of major biomolecules in the body are significantly affected. Elevated level of glucose basically due to the inability of the peripheral tissue, muscle, fat tissue to consume or to take up the glucose, and also at the same time activations of insulin counter-regulatory hormone, which is glucagon, promote the stimulations of gluconeogenesis. Elevated level of unesterified fatty acids, activation of hormone sensitive lipase causes hydrolysis of TAG storage, also lead to increased formations of ketone body, a condition known as ketoacidosis, increased substrate availability for formations of endogenous very low density lipoprotein, and also this lead to the dyslipidemia. And elevated level of unesterified fatty acids amongst the diabetic patient have been shown to further promote decreasing the insulin sensitivity. For the insulin-resistant management, is managed through lifestyle modification in order to restore the imbalance of fuel metabolisms. Overweight and obese individuals basically are advised to lose weight. So basically by practicing what we call as negative energy balance, where they are advised to decrease calorie intakes and to promote the utilizations of the energy to have a regular exercise, and at the same time eat healthily and balance. Balance meaning that all the food groups should be consumed by the patients. And lifestyle modification alone also combined with medications. This is also prescribed. These medications have specific mode of actions with aim to normalize the blood glucose level. First is to enhance endogenous glucose independent insulin secretions. For example, as I explained in the previous slide, sulfonylureas type of medication or group. Medication to amplify the endogenous glucose-dependent insulin secretion, which is glucose like peptide, dipeptidyl peptidase 4 inhibitor. Medication to decrease insulin resistance in hepatic or peripheral tissue, where metformin, glitazones are used. These kind of drugs improve the resistance of insulin, and at the same time able to inhibit or decrease the gluconeogenesis process. Other medications interfere with intestinal absorptions of saccharide or carbohydrate. For example, intestinal alpha glycosidase inhibitors, and also inhibitions of renal glucose reabsorptions with the administrations of sodium glucose transporter, and also medication that targets the ligand receptor, peroxisome proliferator activated receptor gamma, to increase the utilizations of the fuel metabolism. For example, drug class thiazolidinedione. Some adverse effects with the use of hypoglycemic medications or drug have been documented. Abdominal discomfort and diarrhea have been reported with the use of metformin. Edema, weight gain, macular edema, heart failure, fractures, hepatotoxicity with the use of drug class of thiazolidinedione, alpha glucosidase inhibitor, the drug that interfere with digestion and absorptions of carbohydrate or saccharide have been reported with the occurrence of gastrointestinal adverse effects. Other studies also have reported that marketed anti-glycemic agents have shown poor effectiveness in maintaining a long-term glycemic control, thus being associated with severe adverse effect. And hence, this is one of the criteria or important justification that leading to an emerging interest in natural compounds as a novel approach for prevention, management, or treatment of type 2 diabetes. And recently, Wang and colleagues 2022 have reported in their review article that oral glucose lowering agent cause microbiota disturbance or known as intestinal dysbiosis, which may compromise overall host health. Intestinal dysbiosis. Okay, now let me move to the medicinal plants, and subsequently with the properties of medicinal plants having hypoglycemic or anti-hyperglycemic activities. Medicinal plants, the definition, plants that possess therapeutic properties or exert beneficial pharmacological effect on the human's or animal body. And medicinal plants popularly used as traditional medicine in many cultures. And the first speaker have explained in great detail the history with regard the use of medicinal plants. Convenience of accessibility, availability, inexpensiveness, and relatively low risk of side effect, of course, plant-based medicine to be an important alternative source of existing therapies, especially in rural or developing regions. Medicinal plants provide a rich source of biologically active compounds that possess pharmacological activity. And according to various reports, the estimated number of plant species used for medicinal purpose is greater than 70,000, and prospects to develop these medicinal plants are huge. I would like to give rounds of applause, frankly speaking, to the organizers for the great effort in organizing this conference, the first international conference on medicinal plants. I hope next edition of this conference could be held physically to optimize knowledge sharing, networking, etc. As with regard to anti-diabetic properties, 15 plants have been found to possess anti-diabetic properties. This is a review paper done by Vera and Click, published a review article 2022. They carried out a very comprehensive literature search with regard to medicinal plant possess anti-diabetic properties, and they have found that about 100 medicinal plants have good evidence showing anti-diabetic properties. And these medicinal plants basically have been shown to support the traditional medicinal use for the treatments of diabetes mellitus. Okay, at this conference, I would like to share a few findings or experimental studies that have been carried out to investigate anti-diabetics properties of medicinal plants. The first plant is bitter melons or bitter gourd, and the scientific name is Momordica carantia. These plants is one of the most common vegetable in tropical region, particularly in Vietnam, Malaysia, India, China. And bitter melon have been shown to possess strong anti-hyperglycemic abilities, and studies have shown that this plant also contains some insulin protein. Bitter melons have been detection. So basically, in a simple but a comprehensive effects with regard to the way our body metabolizes the glucose. This is isolated bioactive compound that have shown very promising anti-diabetic effect. Okay, second plant, I would like to talk on plant ginseng. This ginseng is one of the most famous traditional plant used in folk medicine for a long time. And ginseng belong to the genus Panax. The root of this plant contains many bioactive compounds. One of it is saponin, and mechanisms of Panax ginseng saponin on different organs related to diabetes shown in the figure. In the liver, it decreases glucose production. In the pancreas, it increases insulin sensitivity. And because of Panax ginseng demonstrated enhanced glucose uptake by muscle and adipocyte, and Panax ginseng, in addition, also causes decreased glucose absorption in intestine. Okay, another medicinal plant that have been shown to possess anti-diabetic activities is Gymnema sylvestre. Anti-diabetic activities of these plants are mediated by stimulations of insulin release, regenerations of beta cell of pancreas, decreased gluconeogenesis, inhibits basal glucose absorption, as well as increased hepatic and muscle glucose uptake. And the study conducted by Ali and Click 2015 have shown that ethanol extracts, Semercapus anacardium's bark, significantly reduce blood glucose level and significantly increase liver glycogen in alloxan's induced diabetic rat. Results obtained by them were comparable to the effect of oral hypoglycemic drug that has been used in their study, which is they use metformin. The ethanol extract of these plants have shown some higher phenolic and flavonoid content and possess good antioxidant activities. Looking at another study, a very excellent study, daily intake of fenugreek containing capsule for 90 days have resulted significant reductions of both fasting plasma glucose and postprandial blood glucose level. In preclinical studies using animal as subjects, fenugreek have demonstrated efficacious against diabetics and delaying carbohydrates digestions and absorptions and enhancing insulin action could be responsible of anti-diabetics properties of fenugreek. In conclusions, a growing body of evidence has shown promising results that support the traditional use of medicinal plants, and more translational research are needed to ensure efficacy and safety, and collaborations among scientists across region working on medicinal plants are crucial to expedite developments and usage of medicinal plants as promising agent for treatments or preventions of diseases. And isolations and identification medicinal plants, bioactive compounds play an important role in improving insight into anti-diabetic functional food and for drugs developments. And before I end my presentation today, I would like to quote two very important verse from the scripture of Holy Quran and Hadith. One of the verse from the Quran that I would like to share here is from Ali Imran verse 191, where Allah Subhanahu wa Taala says, "Rabbana ma khalaqta hadha batila." So meaning that, oh Allah, you have not created all of this without purpose, referring to the abundance of plants that could be regarded as medicinal plant in the world for the benefits of mankind. And the other verse from saying of the Prophet Muhammad sallallahu alaihi wasallam, "Ma anzalallahu da'an illa anzala lahu shifaan." There is no disease that Allah has created except that He also has created its cure or treatments. So with that, once again, I thank the organizer for kind invitation for me to be able to share some insights about medicinal plants and its uses as promoting a potential anti-diabetic agent. So thank you. Back to you, Dr. Agung.
Thank you very much, Dr. Faizul Helmi. Very interesting and nice and also complete presentation. And many important information already presentation, including about the diabetic type 2 and of course about this pathogenesis, and also mainly about the medicinal plant for the diabetic type 2. This very important. So because in my country also diabetic is very high cases in Indonesia, and this hopefully we can develop a good result and also some several products for support this diabetic handling. Ladies and gentlemen, our speaker already finished the presentation and good topic. And now we continue to the question and answer session. All participants, please, if you have any question, you can raise hand directly deliver to speakers, or maybe you write in chat box. So yeah, thank you. This question from Yeah. The first question to Dr. Faisal. Yeah. Yeah. Dear Dr. Thank you for the presentation. I would like to ask for the long-term effect of the medicinal plant on the diabetic patient. As we know, in clinical practice, the desired outcome of the diabetic treatment is not only lowering the blood pressure, but also its effect to the prevent the negative progression on diabetic complications such as heart disease, neuropathy, kidney diseases, etc. Do you observe these advantages in the medicinal plant? Okay, please, Dr. Faisal.
Okay, thank you, Dr. Agung. Thank you to the persons asking that questions. I believe through my reading, at the moment I haven't found any article that have done a very good prospective study in order to see side effect that might emerge from consuming or taking the medicinal plants. So I think that would be my quick response to that question, Dr. Agung.
Okay, sorry.
And possibly Dr. Krupa might have come across with studies that have conducted prospectively.
Oh yeah, please, if Dr. Purpa, you have such a yeah, please.
Sorry. Yeah, like Dr. Faisal said, yeah, there are things that you can get it from online sources. What I know is there are a few studies, not on those plants that Dr. Faisal has presented, but I believe anything that you presented, especially that momordica, which is bitter melon, is widely eaten across the globe, not only in tropical countries, so it's non-toxic at all. And I think it's safe to consume. What I know is I'm acutely aware of curcuma because it's widely used again, not only in India, but although it originated from there, but it's widely used across the globe, including Australia. And you get in capsules. Even if you use for, I don't know, every day, you don't see much toxicity there. So I believe it's safe to consume if people have been consuming that as vegetables or food for how many years, maybe thousands of years. So yeah, definitely, compared to the drugs, prescription drugs, I believe it's safer to consume that without much side effect.
Mm-hmm. Okay. Thank you.
One of the reason when we talk about the toxicity of the medicinal plants, because these type of remedies consume, I can say in entirety in terms of the concentration. When this kind of plant, like what happened for instance, metformin. So metformin basically what is covered from medicinal plant, but because of the concentration, might possibly one of the reason that give toxicity or side effect to the patient. With regard to the medicinal plant, because we are not orchestrating the people not taking too much of, let's say there are a list of bioactive compounds in the medicinal plant, but because of consuming the entire plant, what I say, the preparation will taking most of the bioactive compound will result in less concentrations of bioactive compound.
Yeah. So maybe I have a small little opinions, because if we talk about herbal product, or we talk about multi-compound, right? and not only a single compound. This, I think, this important reason because activity from the herbal will resulting from the resultant from many compounds included in this extract. This is very important. So I think both efficacy or toxicity maybe depend on this. This raw material depend on this extract. So because we talk about this multi-compound. Okay, maybe Dr. Faisal, can you, if any, explain more?
Pardon, Dr. Agung?
Yeah, so you have more explain about this question?
No. I'm done, Dr.
Okay.
Yeah, sorry.
Yeah, so maybe related this question, maybe I also have a short question for Dr. Faisal. So because we talk about multi-compound, which in vitro test and in vivo test suitable for the development of the herbal product for the diabetic type 2. Yeah. I'm sorry, you...
Sorry.
Yeah,
sorry, Dr. Agung, sorry. For the discovery of the drugs from the medicinal plants, I must agree with insight presented by Dr. Furfa, where before entering the clinical phase with utilizing more patient, of course, the first thing we need to fulfill the criteria that we observe either from the chemical assay base, from in vitro, the cellular base, in order to increase the efficacy. So my simple answer, both are required before entering the clinical phase.
Okay, yeah. Thank you, Dr. Faisal. Okay, ladies and gentlemen, now we move to the second question. This question proposed for Dr. Purpa. In your opinion, do we always have to do the isolation? Science, you elaborate so complicated process for drug development. I was wondering if we have more simplified option for the same purpose. Thank you. Please, Dr. Purpa, if you have respond.
Thank you. Don't know the name, but thank you whoever asked that question. Important question as well. I think one of the plenary speaker yesterday, she explained why we need to isolate compounds. There are two things. Now, anything that you are talking about in terms of crude drugs, in terms of mixtures, first thing is it's really hard. It's very difficult to monitor the quality, especially if you're collecting from the nature, from wild, from forest, because it varies from season to season. It varies from place to place. There are a lot of factors that influence the chemical fingerprint of those raw materials or medicine plants. And for that reason, it's pretty hard. And second thing is, there's difference between the extract and the molecules. Now, if you are talking about just extract, then you are talking about traditional medicines. The thing is, if you can substantiate those traditional claims through clinical trials, there are things some countries can accept that. They can approve, different countries have different FDA rules, and they can approve that if you have clinical science to show. But in traditional medicines, most of the cases, because it's practiced in developing countries, we don't have capacity to do that clinical trials. And therefore, we don't get that approval. But, although that formulation of plants may have been used for many years now, and it's safe to do so. But if you require, if you require or if you want to produce that as drugs, that's the only way forward. Partly because there are a lot of regulations assigned by different countries, FDA, and that's the only way that we can go about. There's no other way, and isolating compounds, purified, doing all the toxicity screening, all the clinical trials, phase 1, phase 2, phase 3, and then monitoring is much more easier when you have in the molecule form, and that's the only way. And that's why we have two systems here. Modern pharmaceutical drugs, herbal medicines in a crude form, and if you can substantiate those traditional claims, definitely I think it's worth. And that's why you see, not only in developing countries, even in Australia, US, anywhere you go, if you visit any of the pharmacy shop, more than 60 to 70% of their shop, or you can say over-the-counter products, are based on natural products, based on herbal medicines, right? For example, you have vitamins, you have, some products for arthritis, purely based on herbal medicines, because that's how they market it. But once you make them as prescription drugs, it has to be prescribed by the physician. So therefore, there's certain regulation for that. So that's why you see two components.
Okay, yeah. Ibu Puspitasari, hope explain complete from Dr. Purpa and also clear for you. Okay, we next move to the question from Francisca. Yeah, it is very interesting study using an ethnobotanical approach. You and the team were already doing this research for several years. May I question is how many substances until now which is proven as a potent anti-inflammation? How about the next studies? Dr. Purpa, please.
Thank you, Francisca, for your question. Now, if you're talking about my group's work, not anti-inflammatory compound from different parts of the world, focusing on only my work. So what we have done is, not many actually, we have just started in 2014, 2014, 18, 19, focusing on parasitic small molecules, because parasites emit certain molecules that can reduce the inflammations. After that, then we started working on medicine plants from Aboriginal, used by Aboriginal people. So what happened was, I also work with the Bhutanese traditional medicines. They use more than 300 medicine plants up there. So what we have done is, we have isolated about 45 different compounds. So far, identified more than 200 or so. So what we find is, there are two things we can do when we do the literature review. We just focus on plants that have been not studied before. Whatever plants that have been studied before, you do the review, you find those compounds, see whether those compounds have been tested for anti-inflammatories. That's one thing. So that's not our work. So from there, you may find, as I said in my presentation, about more than 65 compounds. But from our work, we have tested right from in vitro, which is PBMC assay, to preclinical evaluation in mice. So we have so far identified means we have got about at least 4 novel drug-related compounds. So we have patented 2, and others they showed interesting result, but we did not patent that.
Yeah. Okay, thank you, Dr. Purpa. Related this Francisca question, maybe I have one short question, Dr. Purpa. Regarding your experience and maybe also in by regulation in Australia, because bioprospecting, biodiscovery is a big process, is a big activity. Who parties or who institution involved in your collaboration for the activity in the study, and what's the role in its parties? Thank you.
All right. So, yeah, thank you for your question, Dr. Akun. So, for this project, well, there are different universities in Australia, more than 39 or so, right? The big universities, medium universities, they have their own research facilities focusing on different drug discovery that includes cancer, malaria, so working on vaccines. But at GSU, where I work, James Cook University, we have the institute called Australian Institute of Tropical Health and Medicines.
Okay.
So we are research intensive. We have all the facilities here. So you can do biodiscovery, you have molecular characterization group, you have the vaccine development, we have the people who are involved in clinical trials. So from A to Z, so we have all the expertise here. We have immunologists, everything. So I collaborate with them. In terms of metabolomics, then we collaborate. I collaborate with Monash University, Melbourne University, UQ. But in terms of testing our compounds, including crude extract, doing isolations, everything is done here within the university. So we have really strong, you can say, facilities, good facilities here to do all sort of activities, screening. Regarding the, if you collaborate, for example, I have collaborated from University of Wollongong, Macquarie University. So what we do is, when we collaborate, anything we discover, it depends upon who because for doing any biodiscovery, you need a funding. So it will depend upon who gets the funding. For example, if you're the one who gets funding, then any patent, everything belongs to the university that you work for. So, but you have to sign multi-institution agreement with different collaborators because they are also part of that project, but they don't go to the patent application, only if they contribute significantly.
Yeah, very interesting. Yeah, thank you, Dr. Pupa, for this big activity. We of course need good collaboration. Yeah, and with another parties. Okay, we still have three questions. Next from Uswa to Dr. Purwa. I am interested in medicinal plant for infectious diseases, especially to anti-malaria. Some medicinal plant extract, and anti-malaria activity, then the isolate. According to your experience, we should find other isolate or other medicinal plant, or just use the crude extract. Please, Dr.
Thank you, Ushwa. Now, there are a lot of infectious disease. One is malaria, right? And the one is tuberculosis that affects tropics, mostly, PNG, Papua New Guinea as well. So it's important to do this sort of research. And there's huge scope for collaboration, applying for funding together to do this sort of work. And in terms of whether, to focus on isolate or extracts, it depends. Now, because one thing we should know when you're dealing with infectious disease is that, if there's more chances of developing drug resistance, and there's huge scope if you discover some compound, if you isolate some compounds that's effective against especially drug resistant strain of malaria. I have discovered one or two compounds. We got patent application as well for that, for Plasmodium falciparum. So what we did is, we isolated compounds. Crude extract, as I said earlier, was a bit hard. But good thing is, now even in modern pharmaceutical approaches, they recommend multi-compound treatment for malaria infections because, malaria has developed the drug resistance for chloroquine, quinine, even artemisinin, right? So what they are doing is they're doing multi-compound based treatment, which means there's some basis for using the crude extract because it contains multiple compounds there. So it may work or not, but again, like I said, you may have to substantiate that if you want to continue using that. And I believe people in developing countries still use that. And I think, when we cannot afford Western pharmaceutical drugs. I think it's a good way of doing that to prevent malaria infections. In terms of isolates, definitely, yeah. That's the only way you can do it. You have to isolate compounds, and then if you get new compounds, it's easier to patent. You get because there's novelty in it.
Okay. Yeah. Thank you, Dr. Polpa. So we have 5 minutes left. And now, Ms. Sherab Paimon, you raise hand, please, if you have question, but please shortly to deliver.
Yeah. First of all, I would like to thank everyone for kind of like giving me this opportunity. And I am in year 11, currently studying at Armidale Secondary College in Australia. And my question is for Mr. Purba. So you stated that tropical countries are rich in medicinal biodiversity. So, I mean, I'm all for that, and I truly believe in that. But under your drug discovery from ethnobotanical plant, you showed us like a pie graph on the medicinal plants, especially in Australia. And you stated that, please correct me if I'm wrong, because I'm still learning. And you stated that trees are the most common medicinal plants. Medicinal plants in Australia. And so when it comes to trees, like the most important organ that kind of contributes to the making of medicines is the bark of the trees. And the bark, which is like predominantly responsible for improving the integumentary system, which is basically, which makes up like 26% of its contribution to its integumentary system. So I was just wondering, because Australia is in the tropics of the world, is like the bark of the trees for all trees in the tropic region mostly used for improving the integumentary system, or is it just like, does it differ from tree to tree in like depending on the species of the trees? So that's my question, if that makes sense. Thank you.
Thank you. Please, Dr. Polpa.
Thank you, Sharaf. Nice to see you. Year 11, great questions. Very, bold question, I would say. In terms of, whether regarding barks versus the trees. Now, one thing that we need to keep in mind is, tropical countries have trees. Most of the time you find big trees. Also you find herbs, but most of the time I think it's easier to access trees than the alpine countries, for example, like Bhutan or Europe. Most of the time if you go to the extreme mountaintop, you find herbs all the time. And then you see there, most of the time, herbs are the most widely used medicine plants. Now, regarding whether the utility of the bug is based on based on the system that I have classified into community system or not. I would say there's no such classes because it depends from countries to countries, people to people. There are people who use bark for treating skin infections. There are people or plants use vice versa. So definitely it's nothing related to that. So you can use bark for many reasons. And part of the reason could be that, it's easier to access, and also easier to prepare. Now, if you talk about biodiscovery, quinine was discovered from bark of the quinine tree. So there are some correlation there as well. So yeah, great question.
Thank you. Thank you so much for answering.
Polpa, and thank you also, Dr. Polpa. And sorry because the time is over, but we still want question. Maybe please, Dr. Faisal, we can comment shortly. Sorry, will I read? So, Which one? Yeah, from Usfah. I read from the textbook evidence-based phytotherapy that Stevia rabudiana was classified as grade B, preclinical and clinical data established for anti-diabetic. Would you like to explain or describe the use of stevia in Malaysia for anti-diabetic? Because in Indonesia, stevia was famous as a non-calorie sugar. Please, Dr. Valius, but in short.
Okay, thank you, Dr. Agun. Thank you for the person asking the questions about the uses of stevia. In Malaysia, the perceptions with regard to stevia that this compound basically a very good replacement to consume is a very good substitute for the consuming sugar, where I think perception here in Malaysia that the sugar is the main culprit with regard to the developments of a diabetic. So because of that perception, many people in Malaysia thinking that substituting the table sugar, white sugar with stevia, will prevent them from getting the diabetic. So this basically from scientific point of view is totally wrong, because we need to understand from the perspective of the pathogenesis of the disease. So basically the derail of the metabolisms of the fuel metabolism. Yes, definitely one of it due to the derail or consuming too much sugar, pressing too much beta cell pancreas to secrete insulin all the time. The insulins will be desensitized, beta cell unable to cope with the actions that the cell need to consume the glucose. Yeah. And in addition to the stevia, one of the emerging concerns with regard utilizing stevia as the sugar substitution is there are reports on the stevia and it affects on the intestinal dysbiosis. So that's one area to look. And other area to look, there are also studies showing the usage of the stevia with the developments or occurrence of cancer disease. So, Dr. Agung?
Okay, thank you. Ladies and gentlemen, time is over. And we have come to the end of the session. We have done a very interesting presentation and discussion, especially related to the research on the medicinal plan for the tropical diseases, including the anti-diabetic. We hope, we have got a lot of important and interesting scientific information. And thank you for Dr. Purpa, Dr. Faisal, and of course all of participants, and hope we can continue communicate and also open opportunity to for cooperation. Thank you very much, and time I return to the committee. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Dr. Apoteker Agung Heruwibowo, Master of Science, for guiding the plenary session 3 so well. Thank you once again.
The following agenda is awarding certificates to the speaker and moderator of the plenary session 3. The first certificate is for Dr. Purpa Wangchu. Thank you very much, Doctor. And the second certificate is for Dr. Faizul Helmi Aten. Thank you very much, Doctor.
And the third certificate is for Dr. Apoteker Agung Eriwibowo, Master of Science.
Thank you.
Thank you very much, Doctor. We thank you for your participation. Alright, ladies and gentlemen, shortly after this, we will be having our first parallel session of today. Please kindly click the link to the virtual tour and enter the parallel room on your left.
We would also like to kindly remind today's oral presenter to check ICMP's guidebook, which can be downloaded through ICMP's website. Inside the book will be a complete list of the presenters' names, class names, and abstract codes that are needed for the parallel session. There will be a total of 9 oral presentations in each classroom with discussion that the moderator will lead. And if you are presenting today, please enter the classrooms according to the list. But if you are not presenting, feel free to join whichever class you would like.
Thank you and enjoy your time at the parallel session.
Recording stopped.